Alright folks, today we're working on synthetic division of polynomials, which is a really cool thing. So let's pretend like we were asked this question, find 2x to the fourth minus 3x to the third minus 5x to the second plus 3x plus 8 divided by x minus 2. So we would set this up, x minus 2, long division symbol, 2x to the fourth minus 3x to the third minus 5x squared plus 3x plus 8. And then we'd have to divide 1, 2, 3, 4 possible times. That's a lot of places to make some errors in there. So if you're comfortable with long division, by all means, continue to do that. However, today I'm working on synthetic division, and really you shouldn't attempt this one until you have mastered synthetic division, D-I-V-I-S-I-O-N. You shouldn't attempt this one until you've mastered long division, because this is really, it's a shorthand, it's called an algorithm, which really is a basic way of saying a process that you do the same thing until you get your result done. To complete polynomial division efficiently, because we are all about efficiency in math. So, first problem. I'm just going to run through the process one time. We'll do a little bit of notes in there, and we'll just do it a couple more times. So we're asked to solve x squared plus 5x plus 6 divided by x minus 1. And this is a problem that you totally could just do with long division. You know how to make this happen. But we don't need to. We have this new process we're going to learn. So here's what we do. The first thing we do is we do an upside down division symbol. So it looks kind of like this one you see down here. It's an upside down division symbol. On the inside of this, the first thing you're going to do is you're going to write the coefficients. I'm just spelling everything today. C-O-E-F-F-I-C-I-E-N-T, coefficients, only, and I mean only the coefficients, in an upside down division symbol. So our coefficients are just those numbers in the front. So we have a 1, a 5, and a 6. And it doesn't need to keep going over here. I've got some extra space. And then what we need to do is, the second thing we've got to do is we've got to find our test 0. And what I mean by test 0 is we take whatever our divisor is, whatever we're dividing the dividend by, and we set that equal to 0, and we solve for whatever variable it is. So in this case it's x. We're going to add 1 to both sides, and then x equals 1. We're going to write that 0 on the outside. So we'll put a 1 right there. And then the last thing we're going to do is we'll do the same thing over and over here. We're going to add down. We're going to multiply a result by the test 0 and repeat until we're all the way done. So we're going to add straight down. 1 plus nothing down here is 1. We're going to write that result down here. And then multiply 1 by 1. We're going to get 1. 5 plus 1 is 6, so we're going to add straight going down. We're going to multiply by that number in the front. 6 times 1 is 6. We're going to add straight down to get 12. And this, believe it or not, is our answer. So we know that we have 1x squared plus 5x plus 6. So there's a couple things we've got to note about this last row down here. I'm just going to do some over here where I get some space. First off, your quotient, which is the last part, always starts with a degree which is 1 less than the dividend. I believe that's what it's called. Yep, the dividend. Which says if this is your dividend, your degree for this one starts 1 less. So that means that we have an answer which is 1, not x squared, just 1x, and then plus a positive number here, 6, because 6 doesn't have any x's, because if we only have 1x, when we have no x's, that's just no x's. And then our last number here is always the remainder. So this last number here is always the remainder. And that's just where this remainder comes from. Always the remainder. So if the question asks, like when this next question might be, what's the quotient? Well, the quotient is this part. This is our result. This is our answer. The remainder is whatever that last number is there. And we're done. So it's really darn quick. We're going to do this a couple more times just to make sure everybody's got a hold of it. And then as long as you memorize the process where you can do these three things, you can use synthetic division anytime you want to instead of using long division. Hooray! It takes way less time. I mean, this is the whole thing. It's done. That's fast. Okay, so number 2, find, and then this is already set for synthetic division for us. We're going to do a few things. Part A, name the dividend. Part B, what's the quotient? And part C, what's the remainder? So the dividend, let's see here. Just like this one started with our first number, and then we have the next setup, and then we have the next setup. We'll do the same thing here. So we have 8 plus 3x's, and then it looks like we have a minus 5x squared. I'm just counting and adding x's up. So from no x's to 1x to 2x's to 3x's, x to the third to 4x's. So that's 2x to the fourth. So 2x to the fourth minus 3x to the third minus 5x squared plus 3x plus 8 is our original problem we're doing. And then it looks like what's the quotient? So it asks us to figure out the bottom part. So we have to figure out this bottom thing. So we're going to add down 2 plus nothing is 2. Multiply by your test 0. So 2 times 2 is 4. Add straight down. Negative 3 plus 4 is 1. Multiply by your test 0, which is 2. 1 times 2 is 2. Add straight down. Negative 2 plus 5 is negative 3. Multiply by your test number. Negative 3 times 2 is going to give us 6. Add straight down. 3 plus 6. Oh, no, not 6. This is a point where we can make mistakes. Negative 3 times 2 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times 2 is again negative 6. 8 plus 6, negative 6 is positive 2. Part B, what's the quotient? So remember, if this one was, let's see, we have 1, 2, 3, 4, 5 terms, which says we have x to the fourth here. That says this first one's going to be x to the third. So we've got 2x to the third plus 1x squared minus 3x's minus 3 with a remainder of the original dividend. And I'm just going to write that all the way out. It's minus 5x squared plus 3x plus 8. Okay, so here's one thing to note. And we'll talk about this more with the rational root theorem. If we have a remainder, which we have a remainder here and we've had a remainder here. So if we have a remainder, is anything does not equal 0, then the test 0 is not a 0, which says that if the remainder equals 0, then the test 0 is a 0. So, which we'll talk about more about what this exactly means. Remembering zeros are just like an x-intercept is another way to call that, or a solution. And there's one more. 0, x-intercept, solution. Yeah, I'll get back to it later. And so, because this does not equal 0, it's not a 0. It says that at the x-axis, it does not cross at x equals 2. This long thing doesn't cross when it's graphed. We'll talk more about the graphing in 8.3. Okay, last synthetic division problem. So find x to the third minus 1 divided by x minus 1. Determine the quotient and remainder. So we're given the dividend. Don't have to find that one again. We need to find the quotient after we divide it by this. So here's the tricky part about synthetic division. Usually, sometimes you're given every single one. So x to the fourths, x to the thirds, x squareds, x's, down to plain old numbers. But this one has left a few of them out. This is really x to the third plus no x squared plus no x's minus 1. So really, when we're writing our coefficients, we're doing our coefficients in the upside down division symbol. We need a 1, a 0, another 0, and a negative 1. And if you just do 1 and negative 1, you're going to leave out those two important terms, the x squareds and the x's. And synthetic division requires you to have every single one all the way down. Okay, second step, we've got to find the test zeros. So x minus 1 equals 0, so x equals 1. So put a 1 on the outside. So add straight down, 1 plus 1 is 1. 1 plus 0 down here. 1 times 1 is 1. 0 plus 1 is 1, 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, and negative 1 plus 1 is 0. Okay, so this works out really nicely because, as we know, our last number here, just like our last number at the top, is the quotient. It's our last part. And if we have a remainder equal to 0, then this is a 0, which I'm not going to ask you about that now. We just need to be able to say, hey, we definitely got a remainder of 0. So determine the quotient. Our quotient is going to be, okay, so this starts with x to the third. That says this is going to start with x squared. So 1x squared plus 1x plus 1, and the remainder is 0. So if I was asked the quotient, I could just say the quotient is equal to x squared plus x plus 1. We can simplify that a little bit. And we know the remainder is 0. Okay, folks, make sure that you come get your practice from me. Or it's probably in the box, actually. I don't know why you're always telling me, whatever. Go to the box, get your practice, and then get started. And good luck, and remember that synthetic division is just a tool. And if you mess up with a tool, you can always head back to long division and use that one.